Alrighty, today we will look at reviewing some cosine law. This video is suitable for grade 11 3C review, meaning that if you're watching this video, you have already learned your cosine law at one point when you were in your grade 10 math class. This is meant for review. This is not a discovery lesson of a cosine law. The prerequisites we are going to rely on here. We'll rely on your ability to work down with an equation. We'll rely on your ability to substitute values into an equation, and we'll rely on your ability to cosine law, and really our main focus there is how to label your triangle in a suitable way that sets us up for using our cosine law. So we'll start off and we'll look at this triangle. We'll consider which strategies we have already learned when we're working with our triangles, when we're trying to find an unknown side or an unknown angle, and we'll talk about why they will not work. Now, this might look like it has a right angle in here. It's not labeled. We cannot assume there's a right angle. If there's no right angle, we cannot work with our SOHCAHTOA or our Pythagorean theorem, our sum of square strategies. So at this point then, in the past, what we've done is we have just jumped in right away to rely on our sine law. Well, we know how to label our sides and angles for our sine law. We label our opposite sides and angles. We'll work with A, we'll work with B, and then you know what? We actually have a third side here, so we'll call that one C. And we have an angle over here, so we'll call that C because it's opposite to side length C. Now here we've labeled our triangle just as we got used to labeling our triangles when we were working with sine law. The problem is, we practice with sine law, we know what we need. We need two opposite pairs if we're working with sine law. Here we have one opposite pair, our C angle and our C side length, but I do not have an angle for B. I do not have an angle for A, so with only one opposite pair, that tells us that's not enough to work with sine law. So as our last resort option, that's when we work with cosine law. We say it's the last resort because the cosine law formula can be more complicated. It has more opportunities for mistakes than the sine law. Your cosine law has two forms. And we'll always start with the Pythagorean theorem right here, which is really close to what we need. We also need another piece, minus 2 times A times B times the cosine of angle C. This is our cosine law. This is what we're going to use to solve for our unknown side length. Now, when we're working here, we will need to be careful. When we were labeling our triangles for our sine laws, A's, B's, and C's did not matter which way we used them. When we're working with cosine law, it does matter. Whichever opposite pair we do have, which again, we do need one opposite pair for our cosine law. Whichever opposite pair we do have, we must call C if we're using this version of the cosine law because it's the C that appears twice. Otherwise, we're not going to know how to perform our substitution, right? So we have both of our C's in here. Oops, we have both of our C's in here, and now we will perform our substitution. We know that our side length C is what we're looking for, so that's X. We know side length A is 12, so that's 12 squared plus 14 squared minus 2 times 12 times 14 times the cosine of 38 degrees. Now right here, we need to make sure we're following our BEDMAS. So we'll start off by working with our exponents, 12 squared and 14 squared. We're working with 144 plus 196 minus, and here we have this entire piece. Now, because we're only doing this one step at a time, I'm just going to write out this entire piece. This is our working down aspect, cosine of 38 degrees. Now, from here, we cannot perform our addition or subtraction just yet. We must make sure we're performing our multiplication and division first. So that is this entire piece we will need to multiply before we're ready to handle any addition subtraction. Well, that's fine. We can multiply this, but in order to do that, I'll first need to evaluate the cosine of 38 degrees right here. So we can throw that right into our calculator. Good, so we're working with 38 degrees, and we'll take the cosine. Here we are. We're working with 0.788. So that means when I'm copying this down right here, I'll be working with 788. And the rest of my equation, I need to make sure I'm copying the entire piece down. This is me working down. Now from here, now I'm finally ready to perform my multiplication. So 144 plus 196 minus, and I throw this entire piece into my calculator, 2 times 12 times 14 times 0.788. Easy. I end up with 264.77 if I'm rounding. 264.77. Fantastic. Now from here, I'm finally ready, because I've handled my multiplication and division, I'm finally ready to perform my addition subtraction as well. So I'm working with 144 plus 196 minus 264.77, and I end up with 75.23. Now you might fall into a trap and you might say, okay, that means that my C value, my unknown value x, is 75.23. That's too large. Remember, it was not x we were working with here, it was x squared. So now I'll need to square root both sides to get x on its own. And I'm working with x equals the square root of 75.23. That is 8.67. This value seems a little bit more in line with the values that I was working with over here. 8.67. Fantastic work. That's how you use your cosine law to find an unknown side length. Next, one more quick example. This cosine law changes around. If we are using the form that's finding an unknown side length, we're just going to, and I'm just going to give it to you again because this is review. If this was not review, then we would take some time. We would make sure that we practice how to isolate for this into our formula. We're not practicing that right here. That's not our main focus of this lesson. This is the version of the cosine law we need. Again, we label our triangle. We must make sure that our C values have our opposite pair. Our A and B values are off to the sides. Fantastic. Now we can perform our substitution. So we're working with the cosine of our unknown angle theta is equal to 9 squared plus 10 squared minus 15 squared, all divided by 2 times 9 times 10. Fantastic. 9 squared, that's 81 squared. So now we're performing our bedmass right here. Now, we will need to be careful. When we have ourselves a big fraction like this, there are some hidden brackets. Those hidden brackets are around the numerator and the denominator. So if I'm going to perform my bedmass right here, I need to make sure that what I'm working with when I'm working right here, I evaluate my numerator, I evaluate my denominator separately, and then I perform my final division. So 9 squared is 81. Nice and easy. 10 squared is 100. 15 squared, 225. So I'm working with 81 plus 100 minus 225, all divided by 2 times 9 times 10. That is 180. Fantastic. From here, again, I need to respect my hidden brackets right here. I will need to evaluate my numerator before handling anything else. That's 181 minus 225. Negative 44. Okay, now when I'm working with cosine law, I can very well be working with negative values. That's just quite all right. So I'm working with negative 44 over 180 divided by 180. I end up with negative 0.244 repeated. Negative 0.2444 repeated. Easy. Now, that is the cosine of theta. So don't forget, right here, we're not focused on finding the cosine of theta, although that's a step. We're focused on finding what is the value of theta itself. So I will need to perform an inverse cosine right here of both sides. Inverse cosine, I kind of ran out of space, and that's all right, of right here. So I'm working with, these will cancel out. I'm working with theta is equal to the inverse cosine of negative 0.2444. I'll take my inverse cosine over here, and I end up with 104 degrees. Okay, so I have here an angle inside my triangle, 104 degrees. At this point, we've practiced our cosine law when we're working with an unknown side length. We've also practiced our cosine law when we're working with an unknown angle. Again, we use these cosine laws when we're working with a triangle that only has one opposite pair, not two. If we have two, we can use our sine law. If we have only one opposite pair, we're working with our cosine law. I'm hoping at this point you feel a little bit more comfortable. Just seeing these forms working once each will not be enough. You will need to practice this if you're going to work through some of the struggles in your math brain. So I encourage you, head in there, do the practice. Nice work.